Hello everyone, welcome back to Math with Allison. Today we're continuing our series on integration, so we're going to go into some tips and tricks. So let's go ahead and dive into it. We're starting off with an example here, and we are actually going to take the derivative of sine of 2x. So when we do this, we're actually going to have to use chain rule because of this 2x on the inside. So first I'm just going to go ahead and talk it out. We need to take the derivative of the outside. So the derivative of sine is equal to cosine, and then the inside stays totally the same. But we have to multiply by the derivative of the inside. So we have to multiply by 2. So this is equal to 2 cosine of 2x. So let's go ahead and think about what happens when we integrate. I'm not going to worry about the 2x right now. I'm just going to go ahead and worry about this sign. So I know whatever our solution is, when we take the derivative of it, we get positive sign. So let's go ahead and think about some values. In our case, this is going to be negative cosine. So when we take the derivative of negative cosine, we get positive sign. So this helps us find our answer. And remember, the inside still has to stay the same, just like it does for chain rule. So now if we look at our derivative, we have the derivative of negative cosine is for sure sine, but we would have to multiply by the derivative of the inside. So we would have to multiply by a value of 2. Now this changes our answer because we're only integrating sine of 2x. We're not integrating 2 times sine of 2x. That means we have to divide by 2 in order for those to cancel out, which means we have to divide by 2 in what we're taking the derivative of. So that means our final answer is going to be divided by 2 and of course plus c. So that is how we work backwards. So that actually leads us to our tricks right here. Whenever we have a scalar multiple on the inside, so here we have that value of a, we divide by that value of a. So right here the antiderivative of sine is negative cosine. The antiderivative of cosine is sine, and of course we have that a, so we have to make sure to divide by it. And then the antiderivative of secant is tangent, just like everything is backwards for taking the derivative. But of course we have that a of x, and so we have to divide by a. And don't forget, every time we need to add some value c. So let's go ahead and think about this process for e to the power of 3x. So when we take the derivative of e to the 3x, what we do is we multiply by the derivative of the exponent. So the derivative of 3x is just 3. So we have 3e to the 3x. Can we take a guess on what we do when we integrate? If you guess that we divide by 3, you are correct. And also if we add c. So we can go ahead and check this actually. So we have e 3x divided by 3 plus c. When we take the derivative of that, we get 3e to the 3x divided by 3 plus 0. And that leads us to e to the 3x. So this matches with what we're taking the antiderivative of. So I know that this right here is going to be our solution. So that is our general trick right here. First, we have e to the power of x. Doesn't change at all. We just need to add on some value c. That makes sense also with derivatives, right? But when we have e to the power of ax, we have to make sure to divide by that value of a. So let's go ahead and now try this with 4 to the power of x. So when we take the derivative of this, we get 4 to the x, but we multiply by the natural log of 4. So take a guess. What do we think we do? If you thought, hey, maybe we divide by the natural log of 4 and then we add c, you would be correct. So in our case, this natural log of 4 is a scalar. And so what we typically do is we divide by that scalar. And so that would be the case right here. So let's go ahead and check this. We want to take the derivative of it and we want to get 4x. So let's go ahead and differentiate this. So like we talked about, 1 over the natural log of 4, it's just a scalar. So we don't need to worry about it. But when we take the derivative of 4 to the power of x, we get 4 to the power of x times the natural log of 4 plus 0. So here we can see these natural logs of 4 cancel out, and we just end up with 4 to the power of x. So this matches with what we were originally taking the antiderivative of, so we know that this right here is going to be our solution. So let's go ahead and see that in our trick. So when we have any number a to the power of x dx, that a to the x stays the same, but we have to divide by the natural log of a, and of course we have to add our value c. Okay, we have one more, and it has to do with the natural log. So when we take the derivative of the natural log of x, it's equal to 1 over x. So can we think what happens when we integrate 1 over x? If you thought, oh, that's equal to the natural log of x plus c, you'd be correct. We're just working totally backwards. So the trick in this case is that the integral of 1 over x is equal to the natural log of x plus c. Let's see, I have a bit of a tricky example right here. So we have the integral of 1 over 3x dx. What we do in this case, if we're thinking, well, that's not 1 over x, we can rewrite this as 1/3 times 1 over x dx. And in this case, that 1/3 is a constant multiple, so we can bring it out. And now we can take the antiderivative. So this becomes 1/3 times the natural log of x plus c. So if you see a scalar attached to it, don't be scared. You can just go ahead and rewrite it and then take the antiderivative. So that's all I had for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.